Hello all. In this video, we'll be seeing about mode 1 and mode 2 operation of 8051 microcontroller. So 8051 microcontroller is a type of microcontroller, and we know that these microcontrollers are inbuilt with many other stuff that a normal computer is made up of. That is, they have a CPU, ALU, and memory units, and then input-output devices. They are all integrated in a single chip. So we'll be seeing about these mode 1 and mode 2 operations that are related to timers and counters, which we'll come across during the programming of microcontrollers. So let's go into it. So what are timers and counters? Timer is something that gives us precise clock pulses for delays, and then counter is something that is used to count the external events that are happening. And both of these tasks can be done using software techniques like looping statements and different other methods. And looping statements, we are speaking about for loop, while loop, and stuff like that. But these are taking too much of time of the processor, and many important functions are not done. So to relieve the processor of these burdens, two 16-bit timers are used, that is timer 0 and timer 1. Let's go further. And you can see a block diagram or a table like structure given over here. This is how the timer looks. I mean, this is how the timer is created. You have a gate and you have a counter bar timer complement, and then M1 and M0. So this is timer 1 and timer 0. Timer 1 is having 4 bits and timer 0 is having 4 bits. So a gate is something which has the control of the timer. Like if the gate is given a active high input of 1, the particular timer will work or it will get active. And if the gate is given an active low input that is 0, that particular timer will not work. It will stop working no matter what other input is given to the other bits. That is either you give one for counter bar timer, and then M1 and M0. It won't work until unless the gate is active. No matter what other input is given, it won't work. So that is the purpose of gate. It is used to run or stop the timers, either timer 1 or timer 0. And C slash T bar, that is counter slash timer bar. When the input is set to 1, that is active high, it activates the counter or it sets a timer in counter mode. Uh, Over here, you can differentiate, like you can use the timer for either counter or the timer purpose depending on the type of input given. That is either it is active high or active low. So if you give an active low input, as you can see, T bar is given. So it means that if it's T bar and you give an active low, then the timer acts as a timer itself. And if it is a active high input, that is 1, the timer acts as a counter. So counter starts with the active high input and timer starts with the active low input. And depending on the input that you give, whether it's 1 or 0, it'll work as a counter or timer. And M1 and M0. So these M1 and M0 are the operating modes of timers. So these operating modes are what we'll be studying in the session. So what are these operating modes? So while you are working the timer, to specify the task that the timer has to be done, we use these modes. And these operation modes are divided into 4 parts: mode 0, mode 1, mode 2, and mode 3. And these modes are actually specified, or we give these modes by the user input, specifying the type of bits. Like, because it's mode 0 and mode 1, it will be a 2-bit input. Depending on types of 2-bit input that you're giving, you'll be choosing the modes. So you can see over here, we have the mode 1 and mode M1 and M0 given. And then depending on the number types of inputs, you'll be choosing the mode. So if both the inputs of M1 and M0 are 0 and 0, we'll be choosing mode 0. And for 0 and 1, we'll be choosing mode 1. For 1, 0, it will be mode 2, and 1, 1, it will be mode 3. So what are these modes? So let's see, like with an example of assembly language code, what these modes will do. So let's say we give a code of move t mod hash 80. So this move operation over here, let's say first we'll change this hexadecimal code into a binary language. So 8 and you have a 0. So if it's 8 and 0, what is the binary term for 8? It will be 1 0 0 0. And then for 0, it is 0 0 0 0. And you saw that the timers take a 4-bit input on both timer 0 and timer 1. So depending on this input, we can say that the gate of timer 0 is actually uh, not open, that is, it is on active low input, so it's not active. And timer 1 will stay active. So you can see that the timer 1 is active because of the gate input is 1. And you can see that the M1 and M0 are 0. So it will be on mode 0. And if I give an input of 0 and 1, that is, it will be hash 90. So over here, the timer 1 is activated, and then it is choosing mode 1. And then the value, hexadecimal value that's given, hash 90, it will be moved to the T mod. And you should note that the T mod will only take bit values. It is a bit addressable register. So like this, the modes are used. And let's go further in it. So timer modes of operation. The timer may operate in any one of the 4 modes that are determined by the mode bits M1 and M0. So like we saw before, depending on the M1 and M0 inputs, the timer modes will be chosen. So if we choose mode 0, that is a 13-bit timer or counter, depending on the choice. And the value loaded in decimal equals to, and this is the formula that's given to choose the mode, or the bits TL0, TLX, and THX values that you will be giving. Timer high and timer low values that you'll be giving into the program that are decided using these value loaded in decimal. So that is equal to 8192 or 8192 minus delay required by timer clock period. Setting the timer X mode bits to 00B in the T mod register results in using the THX register as an 8-bit counter and TLX as a 5-bit timer. The pulse input is divided by 32 decimals in TL so that TH counts the original oscillator frequency reduced by a total 384 decimal values, that is. As an example, we have an example over here of 6 megahertz oscillator frequency that would result in a final frequency of TH 15,625 hertz. The timer flag is set whenever THX, that is timer high X, either 0 or 1, depending on the type of timer you're choosing, whether it's timer 0 or timer 1, that is the value of X, goes from FFH to 00H. That is, FFH is the highest value of the timer, and 00H is the lowest value, and that is in hexadecimal. That's why I'm mentioning it as H in the last. Or in 0.164 seconds for a 6 megahertz crystal if THX starts at 00H. Over here, this mode 0 mainly does the 13-bit timer counter process. And over here, the value that is counted over here, the value loaded in decimal, will be given to the THX and TLX. So THX takes the higher bit values and TLX takes the lower bit values. So let's say we have a bit value of 0F09. So the 09 will be given to the timer low, and then 0F will be given to the timer high. So now let's see about the mode 1 operation, where it acts as a 16-bit timer or counter. And the formula for value loaded in decimal equals to 65,536 minus delay required by timer clock period. The mode 1 is similar to mode 0 operation, except that the TLX is configured as a full 8-bit counter. And when mode bits are set to 01B in T mode, that is 01 binary in T mode, the timer flag would be set in 1311 seconds using a 6 megahertz crystal. And over here, while the thing we are seeing of 01 binary in T mode, that is what activates the mode 1, as you saw in the table. 00 is for mode 0 and 01 is for mode 1. And now we'll go to mode 2 operation. Mode 2 is actually a 8-bit auto reload, and the value loaded in decimal is equal to 256 minus delay required by timer clock period. All these value loaded decimal that we are seeing the formulas for it, it is actually used to convert the the decimal value into hexadecimal and then load it into the THX and TLX of the respective timers. So the setting the mode bits to 10, that's what activates the mode 2. And in T mode configures the timer to use only the TLX counter as a 8-bit counter. The THX is used to hold a value that is loaded into TLX. Every time TLX overflows from FFH to 00H, that is FF is the highest hexadecimal value to 00 the lowest hexadecimal value. The timer flag is also set when TLX overflows. This mode exhibits an auto reload feature. So the value that is present in the timer will get auto reloaded once again. So TLX will count up from the number in THX overflow and be initialized again with the contents of THX. So what are the advantages and disadvantages of using mode 2 operation and mode 1 operation timer in 8051 microcontroller? Let's see about the advantages. Mode 1 operation timer, as you saw before, it is a 16-bit timer mode where the timer can count from uh, 0000 hexadecimal to highest hexadecimal value FFFF. So the advantages of using mode 1 operation is we have a large range and high versatility. Mode 1 can count up to 65,536 or 35, which is suitable for applications requiring a longer delay or larger count range. And by versatility, we mean that suitable for various timing applications due to its ability to count a large range of values. The disadvantages of using a mode 1 operation timer is that we don't have an automatic reload like we have it in the mode 2 operation and more processing overhead. So because over here we don't have automatic reload, it doesn't automatically reload a value and the software must handle reinitialization of a specific period is needed continuously. And since there is no auto reload feature, additional instructions are needed to reset the timer or to manage the overflow, which can add to the processing overhead. And now let's see about mode 2 operation timer. As we saw before, it is 8-bit auto reload timer mode, and the count values range from 00H to FFH, and the timer automatically reloads with a preset value. So the advantage of using the mode 2 operation is that we have the automatic reload operation and then reduced processing overhead and then consistency. So the main advantage of mode 2 is its automatic reload feature. When the timer overflows, it automatically reloads with the value stored in the TH high bit register, providing continuous timing without additional software intervention. And then reduced processing overhead. The automatic reload mechanism reduces the need for handling timer overflow in software, allowing the microcontroller to focus on other tasks. So we saw that, while you were using looping statements also, that the microcontroller may take a long time. Just like that, even while using the mode 1 operation, it might take a slightly longer time than the mode 2 operation. So to reduce the time taken by the processor, we use the mode 2 operation and reduce its tasks to go through the looping statements, or to auto reload the values given to it. By consistency, we mean that this mode provides consistent timing intervals because of the auto reload feature, which is useful for generating precise periodic events such as baud rate generation in serial communication. And disadvantages of using mode 2 operation is that we have a limited range and less versatility. So mode 2 only counts up to 255 or 256, which may not be suitable for 250 decimals, which may not be suitable for applications requiring longer delays or larger count ranges. Less versatility. Due to its limited range, it's not suitable for all types of timing applications, especially those requiring large timing intervals. So which operation mode is the best? We know that the mode 1 and mode 0 operation are kind of similar, and we saw that mode 2 operation is used for auto reload purpose. So the mode 1 operation is better suited for applications needing a wide range of count values and longer delays, but require more software handling time for overflow. Mode 2 is ideal for applications needing precise periodic intervals with minimal software intervenience, and but limited by its 8-bit range. So choosing between mode and mode 2 operations depends on the type of requirements of your application, and such as the needed count range and importance of automatic reloading. So these are the disadvantages and advantages of mode 1 and mode 2 operation. And we saw that mode 2 is actually more preferred because of the processor being taking lesser time to go through the code, and we'll also be able to auto reload soon. So this is the advantages of using mode 1 and mode 2 operations in the timer, 8051 microcontroller timer. Thank you.